Hello everyone. In this tutorial, we are going to learn how we can categorize a numeric variable. So a lot of times in the data analysis, we would like to change the numeric feature into a categorical feature. So in this tutorial, we're going to learn how we can do that in R, and I'm going to show you how we can do that using base R functions as well as the library called dplyr. So the data that we are going to use in this tutorial is called empty cars. So this is the data set that comes as a with any R installation. It comes actually from the cars package. So if you look into this data, what we see is that it contains different models of cars and data on different features about the car. So if you want to look at the first row, it's Mazda RX-4 model. The mile per gallon is 21. It has 6 cylinders and it has display of 160. I'm not really sure what it means. Horsepower is 110. And you can see the rest of the columns in there. So in this tutorial, we're going to take just one column, numeric column, and we're going to concentrate on that column, and we're going to practice how we can convert that numerical column into categorical one based on different approaches. So coming back here, let's say we are going to look at mile per gallon. So I have already written down the sections in this tutorial. So first section, we're going to look at binary categorization. So let's say we want to categorize the mile per gallon feature into a binary feature, meaning it's going to be, let's say in this case, either it's going to be below the mean or above the mean. So what it means is that we're going to take the mean of that entire column, and then we're going to categorize the rows based on the based on its relationship with the mean. If it's below the mean, it's going to have a, let's say 0. If it's above the mean, it's going to have another value, let's say 1. In the next second section, we're going to look at how we can go beyond the binary categorization. So we're going to see how we can categorize this mile per gallon feature not only in 2 categories, but more than 2 categories. Particularly in this tutorial, we're going to look at how we can use quartiles. So in that case, we're going to break it into 4 different buckets with equal number of observations. So let's jump into the analysis, and we're going to do that by starting looking at the summary of mile per gallon column. So if you run this code summary, empty car $MPG is going to show us this distribution of the column of the data from that column. So we can see the minimum value is 10.40. So a car can go 10.40 miles per gallon, and max there is a car which can go up to 33.9 miles per gallon. And the mean and median, we can look at that. They're pretty close, meaning probably the distribution is very much normally distributed. And we can see first quartile and third quartile. So now we know that what is the mean value from that summary function. So in this section, we're going to use that mean value to create this binary categorization of mile per gallon column. So to do that, first of all, we're going to do that using the base function. So let's comment it out using base function. So what I'm going to do is, I'm going to create a new column for the categorized MPG values. MPG cat bean. Let's say it's coming from base function, so MPG cat base. So this is just a random name that I'm giving to that column to be created. So to do that, what the function that we're going to use is called cut. So cut is basically how it works is, I'm going to write down this as a pseudo function, and then I'll come back here and then write down the actual function. So what it does, it takes the input data. So what it means is that in this context, we need to give it the MPG column, and then we need to provide it with a command called breaks. So what breaks does basically, we need to give it how we want to see the data to be broken down. So if we want to So in our case, we want to see like 3 different bases, right? So we want to see 3 different breaks. So the minimum, we want it to go from, let's say, the first category will be from 0 to the mean, and the second category will be beyond mean to the max. So we need to provide it there. So it's like, it's going to be mean, and then let's say it's cut 1, cut 2, and then cut 3. So what it's going to do is if you give it 3 cuts, it's going to create 2 different portions using these 3 cuts. So it's going to take 1 point from cut 1 to 2, and second category from cut 2 to 3. And as a third point, we need to give it labels. Label means we need to tell it what it's going to call the new categories. So let's say we're going to call it, since this is just pseudocode, let's name 1, or let's say category 2 and category 1. So what cut function does, it takes the input, it uses the breaks to cut the input into pieces, and then it gives it names, different pieces, a different name. So now we're going to use write down the actual function. So to do that, we're going to provide it with this value, which is mpg. And for breaks, we're going to tell it values. So one thing that we can do, we can give it like absolute numbers. We can give it 0, and then the mean value, which is 20.09. I'm looking at these values and then just writing them down here. And then the max value is 33.90. So it's gonna take these values and break down MPG in 2 different buckets. But we can be smarter than that, and we can skip this hard coding numbers. So what we can do, we know that it's mile per gallon is not going to be less than 0, so we can keep 0 intact. But for median or mean, we can use functions, right? We can use mean, and then we can provide it MPG, and then for max value, we can give it max. Also, we need to make sure that in the mean, so we don't know exactly if we have any NA values here, but we know actually there is no NA values. But if you have NA values, just make sure that you include that NA.rm is true. So what it's going to do is going to remove the NA values and then calculate the mean. Otherwise, it gets confused. And for the last max values, we're going to use a function. So we can just call it, let's say, it's the same. It follows the same structure, mpg, and we can give it NA.rm true. So in this data set, we don't have any NA values, so we don't need this NA.rm argument, but I'm showing it to you, so in case you have NA values in your data, you can do that. So before it's becoming too long, so we can break this code into multiple lines so it looks nicer. And the third command we need to give it are labels. So what labels mean is, as we discussed, it's going to be just the names of the different categories. So let's say we're going to call them, let's say below mean, and the second category will be above mean, right? Okay, so that's it. We're pretty much ready to run that code, and I'm going to delete this pseudocode. See, if I run this code, it's already executed. We can look at the data. So now we can see MPG cat base is created, and it has above mean, and there's this below mean categories. And if you look at that, MPG 18.1, which is definitely lower than the mean 20, so it's below mean, above mean 21, and we can check that data here. So that's one way how we can do that. Now we're going to look at how we can do the same thing using dplyr. We're going to start with by loading the library. So I'm using library dplyr to load the library, and then now I'm going to use the code to create exactly the same output that we got. So since we already have this column, we're going to use different column names so that we can distinguish between these two. So in dplyr, I'm also going to apply piping. So piping is, we have already discussed in one of the previous tutorials about piping. So piping is basically this piece of code is called pipe. Using this pipe, you can connect different pieces of functions. So let's say function 1, and then you can deliver it to function 2. So let's say it's function 2. So what it's going to do is, let's say inside this function, it's going to use function 2 is going to use function 1. I'm sorry. Okay, so this is the same thing as calling, let's say, function 2 is a function of function 1. So it's the same thing. This thing is the same thing as this thing, but the benefit of using piping is that it's more intuitive. So you start with this input and then you pass it to this, and then you get something as an output. So that's the basic principle of piping, and I have a separate tutorial where I discuss more about piping. I will also put down that link in the description box. Feel free to go back and check that tutorial. Okay, so for the binary categorization, how we do that. So we start with the first input, right? So the first input is empty cars. So my computer is running really slow. So let's say we start with that first input, and then the second input is what? We need to create a new column. So the way in dplyr we do that, we use the function called mutate, and then we provide it the new name. So let's call it mpg cat and dplyr. So we have given it the new name, and now we need to give it the function using which is going to populate the data in the new column. So to do that, we can do that. It's called if else. So if else, what it means, what we want to see is that if mpg is let's say smaller than mean mpg, and also we can exclude the NA values. So what we are telling it to do is that if mile per gallon is lower than the mean, then call it, let's say, below mean, right? And then, but if else, but if you find that it's not below, then you need to check what is, so what it's going to do, we don't need to actually add another if else argument, we just finish it here. So since it's just a binary classification, so it's either going to be lower than mean or above or equal to mean, right? So the way we were going to do that is we can just mention what it's going to do, what it's going to call the other category. So what this is going to do is that it's going to take this empty car data table or data frame as an input, and then it's going to create a new column, which is going to be called mpg cat dplyr. And then the logic it's going to use is that check if mile per gallon is lower than mean, then call it below mean. If something else, if other than that, then call it above mean. So now if you run that code, we can go back to the data set. We can see there is this new column, mpg cat dplyr, and we can see they are exactly same value are popular in these two columns. But we can make it we can take a look. I'm going to delete these pseudocodes, and we can take a look and match and see what's going on actually. So let's call it checking result similarity. And we can use a function called table. So what I'm going to do is I'm going to look at a tabular look on these two columns. So we're going to see if they have exactly the same value for the exactly same labels. So we have empty cars data, the first column that is called mpg cat base, and the second column is called mpg cat dplyr, and I can run this code. So what it's going to do is going to count how many times they have the same values and not. So we can see that they have exactly the same values. So below mean, so this column, so the rows, these rows are coming from this first input that we're giving it, so the base category, and these columns are coming from this dplyr column. So we can see that they have exactly the same matching numbers. So below mean is 18 for each of these columns, and above mean is 14 in each of these columns. If they didn't match, you would see some of the values on these boxes. Okay, so we're pretty sure that, yeah, both of the functions doing exactly the same thing. And based on your use cases, you can pick either one. So a lot of times you will find that inside function, dplyr is not super friendly. So in that case, you can go with the cut function. But in some cases, when you're doing some interactive analysis, then dplyr is probably the best shot because it makes it a lot easier to read the code after you come back after a while to one of your previous analysis. Okay, so moving on to the next section, now we're going to look at how we can replicate the same learning that we have just learned and do not just binary classification, but more than binary. So to do that, so one thing we can do, we can just remove these two columns that we have already created. So we're going to do that, mpg cat, base is equal to 9. So what it's going to do is going to remove this column that we created here, and we're going to remove the other dplyr column too. So now once this coding, once the codes are executed, I'm going to look at the data. So let's look at the data, and now we see it doesn't have those additional two columns here anymore. So I have removed those because we're going to recreate those columns, but this time we're going to categorize those values differently. So we're going to start with base function. So how do we do that? So let's say in this case we want to categorize the values based on their quartiles. So quartiles means, let's say you have 100 observations, and quartile meaning it'll break it down into 25, 4 buckets, each containing 25 of those observations. So we're going to do that here. So before we do that, let's create a vector where we are going to store the values of the quartile. So let's say we're going to call it quartiles, and then we're going to use a function that comes with our, so it's called quantile. And how quantile works, I have discussed it on the tutorial, but it's basically, it takes an input. So here x meaning it is an input, empty cur. So input is basically we need to give it the column names, and then we need to give it the probabilities. So it's called probs, and the probs are basically, let's say we give it 2.25, 0.5, 0.5, 0.75, and then 1. So if you run only this code, let's say quantile on this thing, so what it's going to do is going to break this MPG into one category between 0 to 0.25, and then 0.25 to 0.5, and then 5 to 0.75, and 0.75 to 1. So it's going to break it down into 4 categories, and it's going to give us the breakpoints. So let's run this code first so that we know exactly what we're getting into. So now we can see that's the 25th percentile is 15.42, 75th percentile 22.8. So now we're going to save these numbers in an object called Quartiles. So Quartiles now contains exactly the same values, because we're going to use this quartile function in the next function. So we're going to use the same cut function here, but in the breakpoints we're going to give it quartiles rather than just binary output. So we're going to so we can actually copy it. So let's say we're going to copy this code. Okay, so we're going to create this new column, and we are using the same cut function, giving it the input and then the breaks. For the breaks, we're going to give it the quantiles or quartiles that we already created here. So this quartile is the same thing as this. So we don't need to give it this max NARM or anything. And then the labels are we need to add 2 more labels. So how we can do that, we can just, let's say, change it to Q1, Q2, Q3, and 4. Q1, Q2, Q3, Q4. Okay, so now let's run the code. And once it's done, we can go back and take a look at the data. Okay, so by the time it's running, let's jump into the dplyr section, how we can do the same thing using dplyr. So it's going to be very similar. So I'm going to copy these 2 lines of code from the previous section. Let's paste it. Okay, So the code has already run. Let's okay, before we jump into the let's complete the dplyr first. Okay, so here's we're doing the same thing. We're creating this dplyr mpg cat dplyr column. We're using this mpg. Yeah. So we'll change that, and we're going to use Quartiles. So the way we're going to do this, Quartiles 1. So let's say we want to break this down is basically, so here what I'm doing is that I'm calling it, let's say if the mpg mile per gallon is lower than or equal to quartile 2, then call it Q1. And then since we have more than 2 categories, we need to use other multiple if-else functions here. But what if mpg is above quartile, above this quartile 2 list function? So what is this? So quartile 2 means actually this 25%, 15.45. So what if the mpg is more than that? There are 2 or 3 more logics, right? So we need to give those things to it. So if else mpg is less than quartiles, so it's going to be less than or equal to quartile 3, and mpg is also going to be bigger than quartile 2. So what I'm telling it here is basically, let's also give it a name. So what I'm telling it here, so first logic it was looking at if mpg is lower than or equal to quartile, this value. Number 2 item from that quartiles vector. And the second logic, what I'm telling it, okay, look for if mpg is less than or equal to this third element, 19.20. And also it needs to be greater than second item from that quartile list, 15.425. So it's gonna take the values that fall between this 15 to 15.425 and 19.200, and it's gonna name them as Q2. And we're gonna use the same kind of logic in the next line too. So now we're gonna give it the function to find out what it's gonna do for the next section, right? So it's gonna follow the same thing. We're just gonna add, we're gonna look at if the mpg is less than or equal to this fourth element, which is this one, 22.80, or it's greater than this third element. Then it's gonna call it Q3. And so we are left with just one more section. And this is, we don't need to add another if else, we can just give it another name. So it's going to be called Q4 elements. So when you write any if else function, you need to be sure that you're including all those possible scenarios. You just need to make sure that you're not like leaving anything out. Otherwise, it's going to lose them in this calculation. So now if I run this function, we get so yeah, it says that I have the object MPT not found. So rather than writing it MPG, I misspelled with MPT. Okay, now let's run it again. So it's calculating and creating the functions. And we're going to look at, once this function is done, calculating it done, we're going to look at how they comparing results. And we can use the same function here as we did. So this one. Before we do that, we can actually look at the actual data set. So we are back with the actual data. So we can see that they have the similar, very same contents created on each of these columns, but they're using the 2 different approaches. And now if we create a cross tab, we can see that it's how it's creating. And they should have the same results. So Q1 and Q1 has 6. If and Q2, 9, 8, and 7. If they didn't match each other, we would have seen some other values populated here. So that's pretty much it, that how you can categorize or bin, how you can do binning on numerical values. Hope you find it useful, and thank you for watching this. I'll put down the related tutorial links on the description section, and if you have any other questions, please feel free to comment. See you in the next tutorial. Thank you.